All right, everyone, I'm Dan Liebenson from Judaism Unbound, and we're here with a special kind of Hanukkah menorah this year. It's going to be a chemical reaction Hanukkah menorah, and we're here with Professor Aaron Dinner of the University of Chicago Chemistry Department, and our assistants, Hannah, Solomon, and Miriam, and we're excited about what's going to happen here. So, Aaron, could you tell us a little bit about what's going to go on in this experiment?
Yeah, we're basically going to make our menorah out of the chemicals that you would have in a glow stick.
Great. And so our idea is that there are 8 of these test tubes, even though normally on a menorah there would be 9 candles, and that's because there's the shamash, which is like the helper candle, and for our purposes that's going to be this beaker of hydrogen peroxide, and that's what's actually going to help the reaction happen, right? So let's do the first night.
Yeah. Essentially, the idea is that you put a little bit of dye into a solvent. Here it's diethyl phthalate, and then we're going to put in essentially an energy source in the reaction. It's TCPO, which is 2,4-bis trichlorophenyl oxalate, and then that's going to react with hydrogen peroxide. The TCPO is going to get oxidized. Trichlorophenyl groups, which are a mouthful, they're big leaving groups that can go very easily. You'll create a high energy intermediate that's 1,2-dioxetane dione, and then that will essentially it'll transfer the energy to the dye, probably by transiently reacting with it. Okay. But the important thing is that energy is going to go into an electron that's going to get excited in the fluorescent dye, and then when it relaxes, it's going to emit light in the visible part of the spectrum. So that's what's going to give the colors. So the hydrogen peroxide plus the TCPO, that's the energy part of the reaction, and then that energy is getting transferred into the dye, and then when the electron in the dye is relaxing down, that's when you get the emission for the...
And why does it burn out? Like, what causes it to end?
Oh, well, basically you just run out of energy, if you will. So as once the electron comes down in the dye, then that energy is lost as heat into the solution. It won't feel hot if you touch it because it's just a teeny amount of energy as it's going. But just like, essentially, once you've mixed together the chemicals to make the high energy reaction, and then it's going into the dye. Once the dye uses it, that energy is just lost to the environment. Yep. Hydrogen peroxide is going to oxidize this, and these are going to be leaving groups. So then we're going to have 2 of our trichloros, and then really the key here is that we're going to make this very high energy intermediate. So that's 1,2-dioxetane dione, and this is what's then going to transfer the energy to the dye, probably by transiently reacting with it, exciting an electron in each of the dyes, and then that electron is going to relax back and emit into the visible spectrum at whatever the appropriate color is. So if you have a higher energy relaxation, then that's going to emit towards the blue, whereas if you have a lower energy relaxation, that's going to emit towards the red. So that's the basic idea. Essentially, you're oxidizing this large molecule of oxalate with 2 leaving groups. That's your TCPO. And then it's making this high energy intermediate. It's going to transfer the energy to the dye. That's it.
Thanks so much. This is so great. A true Hanukkah miracle.
There you go.